So there is a common saying that the solar panel will work only in sunny places in the world, which is in fact not correct. PV panel could work anywhere in the world, but there are some differences in energy production. And here is a solar map where we see that some countries have a high potential to install PV system, and some they have less potential, like in the northern areas of the earth. So is it right the more sun the better for energy system, or for solar energy system? Yeah, we say that a high level of insulation definitely contribute to high performing solar panels. But we need to keep in mind that as the temperature increases, the solar panel performance actually decrease due to the heat effect, and also the panel's efficiency decrease with the high temperature. In this graph actually we see that the different response of different solar PV panel material. We see that some of them work with the little wavelength in this light spectrum, and some of them they are working with the high wavelength. So for silicon solar cells response to the light spectrum, we see that it is mostly working with the visible spectrum and little from the ultraviolet, and due to the fact that the infrared has too little energy to excite the electrons, so there will be no response from this silicon and the infrared spectrum. And the heat losses, or the heat actually is generated and the ultraviolet let's say light spectrum. Or so material actually, as we said, that the temperature has an effect on solar panels performance, and this effect is range from 0.2 to 0.5 percentage of the panel's efficiency per degree per each increase in degree Celsius above the 25 degree. Also we want to say that during summer we are losing some of the energy due to the heat, but we need to keep in mind that during winter, where the temperature is less than the 25 degree, we are getting better performing system in comparison with the summer seasons. And also the temperature in summer could goes up to 65 for the cells. Here is an example of a panel which is operating at 40 degrees Celsius, which has a 100 watt solar panels temperature, and their coefficient or temperature coefficient is minus 0.4 percentage per degree Celsius. So when we calculate it, we found that the panel only could produce 94 watts. For roof installation, we need to keep a gap between the rooftop and the panel back in order to let the air cool the panel and reduce the effect of temperature. So when it comes to the effect of shades can have a serious effect on photovoltaic solar panels, which can cause a hotspot damage to the cell, in which a shaded cell or cell overheats or potentially burned. So the sources of shading are the nearby objects like walls, trees and houses, etc., and from adjacent panels, and also from clouds or dust or any let's say atmospheric condition. So to overcome this problem, we have a bypass diode where the cells are divided into 3 groups or 4 groups in series. Whenever there is a shading in part of that let's say group, that will be bypassed and we are losing part of the panel, not all of the panel. And here is a comparison between a panel that has a 4 bypass diodes and a panel which has 3 bypass diodes. And we see that in case if we are there is a shading in a cell and the 4 bypass diodes, we are losing only 25% of that panel's performance, and 33 in the case of 3 bypass diodes. So efficiency of solar panel is actually defined as how much of the incoming solar energy is converted into electrical power, keeping in mind that the given solar efficiency is under the STC conditions. And for the most efficient solar panels available commercially in the market, it reaches up to 22.7 from SunPower manufacturer. Why efficiency is important? The efficiency value is directly related to the power rating and the size of the panel. So the higher efficient panel, the less space it occupies, and the lower efficient panel, the more space it occupies. So the efficiency can be determined using this formula, where the efficiency is equal to the open circuit voltage and short circuit current multiplied by the fill factor over the input power, and the fill factor is determined by this formula, B max over open circuit voltage and short circuit current. So for panels warranty, we have two types of warranty. We have a product warranty, and also we have a performance warranty. And product warranty, we are talking about the equipment itself, the physical panels themselves, and this includes the manufacturing defect, durability issues, and equipment failure. While in the performance warranty, we are guaranteeing the performance of the panels, that it will degrade with a fixed percentage per year or a fixed loss per year. And here is a comparison between different panels manufacturers, and we see that each manufacturer, they have their let's say they are offering different period for product warranty, and we see that some of them they are offering 25 years for product warranty, and some of them they are offering only 12 years. And power output in 25 years, and yearly degradation, which is related to the performance warranty, also it is different from one manufacturer to the other. And panels warranty, or the panels performance warranty, we have two types also. We have either the tiered warranty or the linear warranty. A tiered warranty, we are warranting the manufacturer warranty that the panel for a period of time it will have a performance, and then after that period it will have a different performance, like this example here. For the first 10 years, the panel's performance is guaranteed that it will work at 90%, and after 10 years it will work at 80% of its efficiency. While the linear warranty, the panel after the first year it will start to degrade with a fixed percentage for each year up to the end of the 25 years.